Hi, welcome to a video on the topic of motion in one dimension. Today we are going to prove the equations of motion. As you can see, there are three equations of motion and we are going to see the proof for the same. And to prove them, we are going to use a graphical approach. So consider a situation where a body is initially moving with a velocity u, then it is subjected to a force for time t, and in time t it attains a velocity v. So u will be called as the initial velocity and v will be called as a final velocity. Okay, we know the fact that slope of the velocity time graph gives acceleration. So here we have a velocity time graph and we want to find the acceleration. For that we'll have to find the slope of this graph. Now to calculate slope, you need two coordinates. So over here this point has coordinate t comma v and this point has coordinate 0 comma u. So therefore slope of this point or this line, which is acceleration, is difference of y upon difference of x, or it is rise over run. So I have v minus u upon t minus 0. So I have a equal to v minus u upon t. I transfer t on the other side, I get at as v minus u. I take u on the other side, I get at plus u as v. So I can write it as v equal to u plus at. So this becomes the first equation of motion. Now we'll see how to get to the second equation of motion. Okay, so going ahead, we use the second property that area under the velocity time graph gives us displacement. Now this is our velocity time graph and the area under this graph will be represented by this thing over here. So this whole is the area that we are talking about, and if we calculate this area we are going to get displacement. So how do we calculate this area? I will divide this area into two parts over here. So this will be my area 1 and this will be my area 2. So I will write over here the displacement is area 1 plus area 2. You can see that area 1, the figure that is formed, is a rectangle. So area of rectangle is length into breadth, and area of the second figure, which is a triangle, that is half into base into height. So over here for the rectangle, this is my length and my length is represented by time, that is t, and this is my breadth. So breadth of this rectangle is u, so this is t into u plus half. Again for the triangle the base remains same, that is t, and this is the height. Okay, we know that since this is v, so v is this whole length and this is u over here, so this length is u. So therefore this length will be v minus u. So I will write here v minus u. Okay, so what do we have over here? We got v minus u, but if you look over here, I can say that a into t is v minus u. So I will replace that over here. So I get s is equal to ut plus half into t into at, that is this. So I get my equation as s equal to ut plus half at squared. So t into t gives me t squared. This is the second equation of motion. Now we'll see how to get to the third equation. Okay, to get to the third equation, we again use the same property, that is area under the velocity time graph gives us displacement. So we will calculate the area again, but this time we'll use another formula. I want you to have a closer look at this figure. This figure looks like a trapezium. Now in a trapezium, uh, these are the two parallel sides. As you can see, one is of length u and one is of length v. This side I'm saying, okay, and this is the height, and then it is connected, so these two become the non-parallel sides. So we have a 90-degree over here and a 90 over here. So the area of a trapezium is half into sum of parallel sides into height. So I have the parallel side as v plus u and the height is t. So these are the parallel side u and v, and this separation is t. Again, taking a clue from here, so this time what we will do is we will take t as v minus u upon a and substitute over here. So I get this as half times v plus u into v minus u upon a. If you observe closely, this is v plus u into v minus u. It's like the math formula a plus b into a minus b, which gives you a square minus b square. So v plus u into v minus u gives you v square minus u square. So here you have v square minus u square, and below a and 2 gets multiplied, that is 2a. So I will write over here 2as is equal to v square minus u square. Let's make some space to write something. So now just rearranging, I bring this negative u square on the other side. I get 2as plus u square equal to v square. So that's my third equation of motion. V square equal to u square plus 2as. So there you have your three equations of motion with an easy proof in a graphical way. Thanks for watching.